an equation in standard form, say 4x minus 2y equals 16. Okay, guys. Now, if I have this equation and I want to graph it using x and y intercepts, the first thing I have to do is identify what are my x-intercept and my y-intercept. If you're not taking notes, it's probably a good idea to. Now, I know, it's so much fun. All right. So, who remembers how you find the x and the y-intercept? Got one, got two, got a few. All right, James, tell me how I find my x-intercept.
We subtract the number with the x with the same number.
What do you mean by that? We're not solving for y. Is that what you're trying to do? We're looking for an x-intercept. That's a little different than the solving for y that you did. Let's see. Tanner.
If you want to find the x-intercept, you have to put y as 0. Y equals 0. So then it's like y. It's like 4x minus 2 plus y plus 0 or times 0 equals 0.
All right.
So it's just 4x.
Okay, so Tanner's got it right here. If we're looking for the x-intercept, the most important thing to remember about the x-intercept is that it means that y equals 0. Does anyone remember why y has to be equal to 0 at the x-intercept? Kaylee?
Because when you're graphing things, y can't have a value in order for the x to be on the y.
Okay,
You know what I mean?
close except for 0 is a value. It's just
Well,
not,
yeah.
it can't have a positive or a negative value. It has to be, the value of it has to be 0. So, yes, 0 is an important number. Don't mistreat 0. It has value, okay? So,
But isn't 0 the number that has no value?
no, 0 has its own value. Just
0 has its own emotional value.
All right. So, in order for it to be the x-intercept, it has to be on the x-axis. And if you look at lines that are on the x-axis, the one thing they all have in common is that they are up or down, none, right? So the y value for every single one of these points would be 0, right? So if I have a line and I am looking for its x-intercept, then I need to look where its y value is 0. So the easiest way to find an x-intercept is simply let y be 0. And the nice thing about when you have an equation in standard form is that if y equals 0, that means one of your term essentially just doesn't exist, right? Because 2 times 0 is 0, and 4x plus 0 or minus 0 is 4x, right? So it's like that term doesn't even exist, okay? So if you have an equation in standard form, if I want to find the x-intercept, I basically just ignore the y term, right? So I have 4x equals 16, and if 4x equals 16, then I would divide by 4 on both sides, and I would get x equals 4. So my x-intercept is 4, comma, 0. Important thing to know here, your x-intercept is a point, and a point is named by two numbers. Now, one of the numbers is guaranteed to be 0 because, remember, that's how we found our x-intercept. We said, y will be 0, and then we found out what x would have to be in order for y to be 0. Now, how do we find the y-intercept? Josie? Right, okay. So the reverse is true. If I'm looking for the y-intercept, well, if you're looking at a graph again, if it's going through the y-axis, then they are in the middle horizontally, which means they're left none and right none, which means your x value would be 0, right? So if I want the y-intercept, that means my x value has to be 0. So it's kind of backwards. If you want x-intercept, not x but y is 0. If you want your y-intercept, not y but x is 0. So we have this term is unimportant now, right? If x is 0, 4 times x is 0, and 0 minus 2y is negative 2y. Don't forget that minus sign is attached to the 2y part, not to the 4x part. So when the 4x goes away, you still have minus, so negative 2y. And so if I have negative 2y equals 16, if I divide through by negative 2, I get y equals... I heard a couple of answers. 16 divided by negative 2 is negative 8. That's my y value. My x value is 0. So my y-intercept is 0, negative 8. Now, if I want to graph this, do you want a bigger graph? I can make it a bigger graph. Is that better? Okay. So I need to graph 4, 0, and 0, negative 8. So 4, 0 means I go to the right 4. 1, 2, 3, 4, and up none. Which of course makes sense because that is the x-intercept. So of course it's going to be on the x-axis. And then I have to graph 0, negative 8. So that time I go to the left or right none, and I go down 1, 2, 3, 4, 5, 6, 7, 8. Now, is that my solution to this equation? Okay, the line is really, really important. How many solutions does 4x minus 2y equals 16 have? A million is actually a really small estimate. Infinite, okay? So compared to infinity, a million is tiny, okay? It has an infinite number of solutions. How many solutions do I have right now? I just have 2, okay? You cannot graph 2 points and tell me this is the solution to this linear equation because it's not even close. It's 2 out of infinity solutions. So if we gave you a grade based on how many you got correct out of how many total possible there is, that would be 2 divided by infinity. You would be failing, okay? So make sure you draw the line connecting them. It is not complete without the line.
You can't divide something by infinity because infinity has Haley, she's just saying
Exactly, that's why
she's just saying that.
Well, I mean, you couldn't get an actual exact value, but I can divide it enough to be able to tell you that it wouldn't be good. So there's actually stuff that you'll study later on in high school called limits. And when you're doing graphing with limits, and it talks about as you approach infinity, what happens. And Yes, as you approached infinity, your grade would be approaching a 0. So it would not be good. So anyway, my line got really crooked there at the end. Anyway, I'll just ignore that part. Okay, so this is what this line looks like, and a line extends infinitely in both directions. So, and draw the little arrows to say, hey, it goes on forever, which is how we can say that it actually encompasses an infinite number of solutions. Because since it goes infinitely in both directions, it has an infinite number of numbers on it, right? So, this line would be the solution to 4x minus 2y equals 16. So remember, like any point that I choose on this line, like this point right here, to -3, would be a solution to that. Now also, this point, which is, 2.6 and -2 something, that would also be a solution. Okay, obviously I don't know what the exact values are, but any point on this line will be a solution. Every single one. All right. So that is not the only way to find a linear equation, to graph a linear equation. In fact, in this chapter we'll learn 3 different ways to graph one. Today we're going to learn 2. So, or I should say we'll review one, because we actually learned that Tuesday, and we're going to learn a new one, which is to graph using a t-table. Now, a t-table, a t-table is called a t-table because it looks like the letter T. We're very inventive in math with our naming of things. It's like our quadrants on the graph. Exciting names like 1, 2, 3, and 4. Okay, so we put a lot of thought into things. So we call this a t-table because it looks like a lowercase t. All right. Now, if I have an equation that I'm going to solve using a t-table, a t-table is more helpful if you have an equation that is in y equals form. So let's say I have y equals -3x minus 4. Now, when you create your t-table or t-chart, what goes on the left-hand side is going to be your x value, and what goes on the right-hand side is going to be your y value. Now, the reason it's x then y, if you remember back to when we first introduced the idea of functions, and we talked about x and y, and we said, okay, the x can be called the domain, and the y is the range, and then we also said the x is the input, and y is the output, and x is the independent variable, and y is the dependent variable, okay? When we look at linear equations, we always think of x as being what we control, and y is what happens as a result of what x is. So in a t-table, what we're going to do is we're going to choose what we want x to be. Now, what can you choose as your x? What, Cam? Anything. Your x can be 7 million if you wanted to. It can be -3. It can be 2.75. It can be 21. However, while it can be anything, keep in mind that you are going to be graphing this. So if you pick a gigantic x, what are you going to have to do? Make a gigantic graph. So since that's generally not what we want to have to do, my suggestion would be to pick itty tiny x's. Okay? That way you don't have to make such a big graph. And if it's in y equals form, the absolute best, easiest thing to use for x would be what?
1.
Nope.
0.
0. Because just like in our examples where we were looking at x and y intercept, if you let x be 0, then this term right here No.
Nothing.
It's nothing. It goes away. If x is 0, then the x term is basically non-existent. Because negative 3 times 0 is 0. And 0 minus 4 is negative 4, right? So, if we do this, my y value is just going to be whatever else is left after you get rid of your x term. So 0 is a really, really easy one because even if you're not good at math, you know, you can figure that out. Just block out the x thing and whatever's left, that's your y value. All right. You can use that for as long as it's in y equals form, yes. Okay. Now, this is only one solution though. Okay. Because if I graph 0, negative 4, can I draw a line? Well, you can, but it's not the right, yeah, you don't know which direction it's going to go. I mean, you can draw a line that goes through 0, negative 4, but from there to where? Yeah, there are an infinite number of lines going through 0, negative 4, so we need to know which one of those infinite lines is y equals negative 3x minus 4. So we're going to need more than 1 point. So what other value can we use for x?
13.
1.
Do you really want to have to graph to 13?
1.
And more importantly, I'm going to take 13 and multiply it times negative 3 and then subtract 4 from it. So 13 times 3 gives us 39. So now you're going to have to do a graph that goes out to 39 plus another 4. So now we're talking about drawing a graph that goes out to 43. Raise your hand if you want to have to graph out to 43. Okay, you go for it. That's your extra assignment for homework tonight. Okay. I'm just kidding. You don't really have to do that. All right. Now, so how about a small x value that you would like to use? Hannah? 2. All right. So if we use 2, all that means is we're replacing x with 2. So I have negative 3 times 2 minus 4. Order of operations, say I multiply first. So negative 3 times 2 is?
Negative 6.
Okay. Negative 6. And then minus 4 gives me negative 10. Now, can I draw a line now? Yes, 2 points is enough. However, I always recommend doing at least 3. Main reason why I recommend doing at least 3, if I draw 2 points, there will always be a line through that goes through those 2 points, right? If I draw 2 points, like say I draw one here and another one there, is there going to be a straight line that goes through those 2 points?
Yes.
Yes. Okay. If I draw this point here instead, is there still going to be a straight line that goes through those 2 points? Yes. So if I mess up on one of those points, could I still end up with a line going through them? Yes. But if I do 3 points, is there always going to be a straight line that goes through 3 points? No. Okay. So by doing 3 points, you give yourself a little bit more certainty that your 3 points are right, because if they're not in the line, then they're not right. These are linear equations that are always going to be on a line. Okay. So if you're getting 3 points and they're not on a line, then you messed up on at least one of them and you should go back and check your work, right? So I always recommend doing at least 3 points. So someone pick their favorite small values. Jake.
8.
Small. Okay, 8 is not too bad, but 8 times 3 is going to be 24, plus another 4 is going to be 28. I don't want to have to graph to 28, do you?
3.
All right, Cole.
4. 3, 5, 7, 9.
Negative 8.
All right.
Negative 2. Negative 8.
All right. Cole says 3. All right. Let's look at 3. 3. If I replace 2 here, my x is now 3. Now I have negative 3 times 3, which is negative 9 minus 4, which is negative 13. Now, personally, I would have gone with like 1, or I would have gone with like negative 1 and gotten even smaller. But, you know.
If you did 2 and then the y is negative 10, if you did negative 2, would the y be 10?
No. let's do 2 here. We'll do one more value just so we see. All right, if x is 2, no, I meant -2, sorry, thank you. All right, so if I do -2, then I have -3 times x, which is -2, minus 4. Multiplication comes first, so -3 times -2 is positive 6, and 6 minus 4 is 2. So, all right, so now let's graph this one. I may have to use the tiny grid paper this time, y'all, with your not very small numbers. All right, so gonna have to keep extending it in the negative direction here. All right, so here we have our graph. We need to graph 0, -4. So I'm going left to right none and down 4. Then I need to graph 2, -10. So I'm going to the right 2 and down 10. Let's see. 3, 4, 5, 6, 7, 8, 9, 10. I have a random red dot. Ooh, I forgot that. We'll do that. All right, and then I need 3, -13. So it goes 3 and then down to -13. And then I also added -2, +2, so to the left 2 and up 2 gives me this. Now, do all of those lay on the same line?
No. Yes.
Let's look.
I believe.
All right, so I'm going to start at this top one, and I'm going to stretch it down, and yes. Yeah, mine aren't perfect because for some reason when I go to draw dots on this, it does funny things. So anyway, if they were perfectly on the meetings of those, then it would be a lot better looking, but you know, it'll be all right. So our solution here is this line.
You come to this classroom with an empty thing.
Yeah, showing up empty-handed is terrible. All right. So our solution to this equation is this line right here. Now, on your homework tonight, it is a practice section from the workbook. However, one thing I don't like, in the section, they teach you how to do X and Y intercepts, and then in the textbook and in the workbook, never do they have a question on graphing using X and Y intercepts. So, I have added 5 questions to a Google document that is in your homework section on Google Drive. So the same place where I put those 2 word problems the one time, there is now a one, I think it's just called X and Y intercepts or something like that, finding X and Y intercepts. It should be under your Drive, like your math folder that I had you put things into. It should be in there. So, all right, now listen, guys, we're not done. There's still one more thing that you're going to have questions about if you don't pay attention. All right, now, so for your homework in the workbook, they're going to ask you for 4, like the first several questions ask you to find 4 solutions to an equation. So that's just like what we just did, except we graphed it. But hey, there's one solution, 0, -4, 2, -10, 3, -13, -2, 2. In other words, all you have to do is create a t-table, pick 4 x values, and find the corresponding y value. And that's okay. They're not all in y equals form, but do you know how to put them in y equals form? Okay, so if there's only like 2 that aren't already in y equals form, but if they're not, hey, we kind of went over that. for like 2 days. So you can put them in y equals form and then create a t-table. Now, x, like finding x and y intercepts. Yeah, just look for the one that was added today. All right. Now, the one thing, then the next section asks you to graph. It gives you several equations and it asks you to graph them. Most of them are already in y equals form. That's why if some of those had been in standard form, then I would have left it at that and you could have used the x and y intercepts on those, but none of them are in standard form. They have like every single one of the graphing one is in y equals form. So, for those, you can create a t-table and then graph them. Okay, and then to practice with x and y intercepts, you just need to do the extra 5 questions. However, listen, there is at least one, if not a couple, that might trip you up a little bit.
Yes.
Because they look like
-7.
now. If I were to create a t-table for this,
Where's James? Is he in here and stuff for you? I think you left this
Alright.
after amount. It was brought back today.
all right. Now, pick a value for x. What do we want x to be?
0.
Okay, 0. Hannah, what do you want it to be? 3. Cameron, what would you like it to be? -1. All right. We'll pick one more. Emma Grace. 2. All right. Now, if I let x be 0, what is y going to be?
-3.
0. -3. 1.
Look at the statement. It says y equals.
-3.
When does y equal -3?
When y equals
All the time.
Okay, it doesn't say y equals -3 when x is 2. It says y equals -3. That means always, always, always. So I could just go ahead and fill in. This time our y variable is really not dependent on x. So really you could pick anyone. And the thing is, this is going to look like.
That should be easier than the other one.
Yeah, it is. It is easier than the other ones. It's just that if you hadn't seen it, then you would be like, what did I do here? So, I have 0, -3, which would be down here. I have 3, -3, which would be down here. I have -1, -3, and I have 2, -3. So, I get a, specifically,
Those are parallel with x-intercepts.
right, guys, if you have y equal to something, then you're going to get a line that is parallel to the x-axis. So if y equals a constant, then it's going to be a line that is parallel to the x-axis. But is the y value here -3?
No, 5.
Yeah, if y is -3, that means it's 3 below the x-axis. Is this 3 below the x-axis? Yeah. Okay, so what, guys? So what if the equation was x equals 4? What do you, guys, what do you think x equals 4 would look like? Kaylee?
It'd be something parallel to the.
No, it would be 4
Okay.
to the right, parallel.
Right. If x equals 4, then that means it's 4 units to the right of the y-axis. So that means this line right here, everything along this line is 4 units to the right.
So x equals
So this would be x equals 4.
Okay, bye.
So those are the only 2 kind of special cases. Everything else you can use a t-table or x and y
We have
intercepts.
several announcements. First of all, I'd like to